Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to our first lesson, Introducing Derivatives. In this unit, we will learn the mathematical and geometrical meaning of the term derivative. We will determine the differentiability of a function at a point and find the derivatives of selected functions over intervals. We will apply the sum, difference, product, and quotient rule of differentiation in functions. We will also find the derivatives of power functions, polynomial functions, rational functions, trigonometric functions, exponential functions, and logarithmic functions. We have a great deal to learn, students. Are you ready? We have made position time graphs in previous grades, wherein the position of a particle is represented by the y-axis, and the time is represented by the x-axis. In these graphs, speed is represented by the gradient, or slope of the line. Let us try a review activity, students. Draw a position time graph for these data. Then, find the gradient of the graph and determine the speed of the particle in these intervals.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. Here is what your position time graph should look like. Since the graph is a straight line, we can determine its gradient by comparing two successive points. The interval from 0 to 1 has a distance of 2. 2 minus 0 equals 2. So, the gradient of the graph is 2. Therefore, the speed of the particle is 2 meters per second for each of the intervals given. I am confident that everyone in the class found the same answer. That was a simple review exercise, was it not? Now, let us learn to make a position time graph that is not a straight line. Suppose a particle moves along a straight line from point O on that line. The positions of the particle from point O at a given instant of time are shown here. We can see from the table that different distances are covered in equal intervals of time. Therefore, our position time graph will not be a straight line. Let us verify this by drawing the graph. We can plot each point from the table of values, then we draw our line. If we designate A through F to be each individual point on the graph, we can find the gradients of the chords AB, BC, CD, DE, and EF. Notice, students, that the average speed over each interval of time corresponds to the gradient during that interval. It is time for our second activity. A particle moves along a straight line from a fixed point O on that line. The position D in meters of the particle from point O as a function of time t in seconds is given by D equals t plus 4 times 3 minus t. First, draw the position time graph for the interval t equals 0 to t equals 5. Using the graph, find the average speed of the particle over each interval. Find the time at which speed is 0 and approximate the gradient of the graph at t equals 2. Please get started right away, everyone.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Here is the table of values for this function. Using the table of values, we can plot the graph of D. Next, let us find the average speed of the particle over each interval. Time interval 0 to 1 is marked by chord AB. 10 minus 12 equals a gradient of -2. In this way, we find that the average speed of the particle during the interval is -2 meters per second. The average speed for interval 1 to interval 2 is -4 meters per second. The average speed for interval 2 to interval 3 is -6 meters per second. The average speed for interval 3 to interval 4 is -8 meters per second. The average speed for interval 4 to interval 5 is -10 meters per second. As we can see from our table of values, D equals 0 when T equals 3. Now we must approximate the gradient by using what we have discovered, that D equals T plus 4 times 3 minus T. Note that the gradient at any point C is determined as the gradient at C equals delta D minus D over delta T minus T. Let delta T be the increase in time and delta D be the increase in distance. If T equals 2 plus delta T, then delta D equals 2 plus delta T plus 4 times 3 minus 2 plus delta T. This simplifies to 6 plus delta T times 1 minus delta T. Since at T equals 2, D equals 6. The gradient at C equals 6 plus delta T times 1 minus delta T minus 6 over 2 plus delta T minus 2. We can expand and simplify this equation to negative delta T squared minus 5 delta t over delta t, or negative delta t minus 5. Therefore, as delta t approaches 0, negative delta t minus 5 approaches negative 5. So, the gradient when t equals 2 is negative 5. I hope you did not have too much trouble with this exercise, students. We must get lots of practice with derivatives. That is all for today's lesson. We have begun to learn about derivatives by learning how to make a distant time graph that is not a straight line. We have also learned to approximate the gradient of a curve at a given point. In the next lesson, we will learn the graphical definition of derivatives. Until then, thank you, teacher. Thank you, students.